Hello everyone. In our last class we have discussed chemical bonding. Then today we are going to discuss one more new chapter. It is called as Principles of Metallurgy. Principles of Metallurgy. You have already learned in your previous class, in 8th class, about the metals and their properties. Metals can lustrous, metals can show ductility, sonority, so and so. That characteristics you have already learned in your 8th class. Okay? Right? Today we are going to discuss from where we get metals, how we collected those metals, that we are going to discuss now. Okay, then actually what is metallurgy? Sir, what is metallurgy? Metallurgy means the process of extraction of metals from their ores. The process of extraction of metals from their ores is called as metallurgy. Then the process of collecting. Here you know that from where we get metals, sir? We get the metals from earth crust, from nature. Okay, from nature we collect the metals. Okay, seawater contains many salts like sodium chloride, magnesium chloride. From that sodium chloride we collect the sodium metal. From magnesium chloride we can collect magnesium as metal. Okay, that process, the process of collecting, how we are collecting the sodium from the sodium chloride. Okay, from the sodium chloride is known as metallurgy. Okay, the process of collecting the metals from their ores, Then what is ores, sir? What is ore? We will discuss now. Right? The elements, the most of the elements or will not get in free states. Some of the metals will get in a free state. Such as what? Gold, silver or platinum, or some of the metals we get in their free state. That means they have very less reactivity, like gold or silver. Okay, these have very less reactivity, so that's why they will not combined with they are not combined with other compounds. So that's why most probably we will get gold as in pure state. But most of the metals can be available in state of combined. We will get in combined state, right? Like for example, aluminum combined with some oxides. Okay, or like copper or combined with the sulfides, like that we can get it, right? Like in a combined state, right? Then the elements or compounds, of the metals which occurs in nature in the earth crust is called minerals. That is called as minerals. Minerals means what? The elements or compounds of the elements, okay, which occur in nature in the earth crust are called as minerals. Okay, right? Then the minerals from which the metals are extracted without economical loss are called as ores. Okay, here for example, aluminum can available in most percentage in our earth crust. The element Al can available in mostly in earth crust. Then wherever where the aluminum deposits are present, there we can dig it and we can collect that mineral. We can collect it. That source is called as mineral. Okay, right? Then here we get the aluminum in many kinds of minerals we have to get aluminum. But here the bauxite, if we collect the aluminum from the bauxite, it gives very less economical loss. Very less economical loss. I will give you one simple example. Okay, right? So here we have spent 1,000 rupees. Okay, we have kept 1,000 rupees for collect the aluminum from one mineral. There we get only 40% of aluminum. When I spent 1,000 rupees to collect the aluminum from the mineral, there I get only 40% of the aluminum when I spent 1,000 rupees. Right? The next time I have spent the same amount of oresa, 1,000 rupees on another mineral to get the aluminum. Then from that mineral I get 60 to 70% of aluminum. 60 to 70% of aluminum. See here, where we get more quantity of aluminum in second case. Here in which case, sir, actually we get both the cases 1,000, but in which case we get more quantity of aluminum in second case. That means in which case it is profitable. So getting of 70% is profitable, or 40% of aluminum is getting is profitable. Yes, here 70% of aluminum when I spent 1,000 rupees on one mineral. That means, for example, bauxite. Okay, if I use it to collect the aluminum, I spent 1,000 rupees on bauxite, I get 60 to 70%. Same 1,000 rupees I kept on another kind of mineral, but there I get only 40%. So it is profitable. When we will get more quantity of element, that is profitable. Okay, so those minerals are called as ore. Those minerals are called as ore. Ore means what? The minerals from which the metal are extracted without economical loss. Without economical loss. See here, bauxite is the mineral. The aluminum is a metal. Got it? Here bauxite is the mineral and aluminum is a metal. I get more quantity. That means very less economical loss is occurred in when I use it to take aluminum from the bauxite. But in first case I get only first 40%. So here bauxite is called ore. Then here I used let X mineral I use it to collect the aluminum. So this X will not be considered as ore. This bauxite is considered as ore. Ore means the mineral from which the metal are extracted without economical loss is called as ore. That means here you have to know one thing. All ores are minerals. All ores are minerals. But not all minerals are not ores. Here all ores are minerals, but all minerals are not ores. Okay, right. And here we have some ores. Here on the board, here it has some ores, then their formula and their which metal we can able to collect. Okay, bauxite is the ore. Its formula Al2O3 2H2O. Al2O3 2H2O. That means it contains 2 moles of water molecule. Right? Okay. And from the bauxite what we can get? Aluminum metal. We can able to collect the aluminum metal, right? Then copper iron pyrite. Okay, copper iron pyrite. This is one more ore. Its formula is copper CuFeS2. CuFeS2. See here. Here the thing is, what this ore is copper ore. Here from this we can able to collect the copper and we can able to collect the iron also. Fe means iron also. But if we want to collect the iron from this ore, that is not profitable. From copper iron pyrite, the collecting of iron is not profitable. But collecting of copper from copper iron pyrite is the profitable one. So that's why the copper iron pyrite is called as ore for copper. Ore for copper. Here we have hematite. This is one ore. What is the formula? Fe2CO3. From this also, from this or this mineral, from this mineral we can collect iron. Here it has a chance to collect the iron from this copper iron pyrite also. But here the collecting of copper is profitable from here. But if we want to collect only iron from this mineral, it is not profitable. Then it called as a mineral in case of iron, but it is called as ore in case of copper. Here hematite is called as ore of iron. Why? Because here we can get more quantity of iron. Like that, zinc blend, ZnS, formula is ZnS, zinc blend, formula is ZnS. We can collect the zinc. We can collect the zinc. So zinc blend is a ore of zinc. And here magnesite, MgCO3. Here it is the magnesite is ore of magnesium metal. Okay, magnesite is the ore of magnesium metal. Like Epsom salt. What do you call? Epsom salt is the ore of magnesium. Right? That formula, magnesium sulfate, MgSO4 7H2O. This is the formula. Here it has seven water molecules in the compound. Right? And here hematite is ore for iron. Okay. Then rock salt. Then its formula is NaCl. The rock salt is ore for sodium metal. And cinnabar, HGS. Hg is the metal we can collect. That means the Hg's ore is cinnabar. Okay, right. Magnetite, Fe3O4. Magnetite is also a ore for iron. And galena, PbS. Then it is ore for Pb. And gypsum is formula CaSO4 2H2O. CaSO4 H2H2O. So gypsum is ore for calcium. And here limestone is ore for calcium. Ca, its formula CaCO3. And cornellite, KClMgCl2. Then it is also a ore for magnesium. And here horn silver. Next one is horn silver. It is the ore for silver. AgCl is the formula. AgCl is the formula. Here are the sum of the ores are given. Then you have to remember it. You should know the name of the ore, formula of the ore, and metal available in that ore. Okay, you have to know the name of the ore, formula of the ore, and metal, both. Okay, right. And here you can see it. See from these ores. This ores contains most of the oxides and most of the sulfides and carbonates and sulfates, isn't it? Right. Okay, here it has oxides and sulfides. So here it has carbonate groups. Okay, that means mostly the ores are present sulfides and oxides, right? Oxygen and sulfur, these two are in 16th group in periodic table. We have already learned 16th group of periodic table is called as chalcogen. What we call chalcogen, that means chalcogen. Okay, right. Then here from this we came to then later on, then after we came to know that the metals are arranged in descending order of their reactivity. Descending order of their reactivity. That is called as reactivity series. Okay, Nana? Reactivity series. Reactivity series means what? The arranging of the metals, they are descending order of reactivity. Their descending order of reactivity is called as reactivity series. Here K, potassium, sodium, calcium, magnesium, aluminum, these are highly reactive elements. And here zinc, ferrous, lead, copper, these are moderate. They have moderately reactivity. They have highly reactivity. They can react. Most probably these elements, these metals are present in combined state only. Right? Then here very low reactivity, Hg, Ag, Pt, Au. That means mercury, silver, gold, platinum, or very low reactivity. That's why most probably we get in free state only. Okay, this is about the minerals and metallurgy and ore and some ores. Now we are going to discuss how we can collect, what are the methods, what are the processes we are following to collect the metals from these ores. Okay, right. Here extraction of metal from the ores. This extraction is mainly depends on 3 steps. Okay, first one is concentration or dressing. We call concentration or dressing. Next one, extraction of crude metal. And third one is refining or purification of the metals. Okay, right. Here first we are going to discuss concentration or dressing. Okay, right. Here mostly we can collect the ore from the earth crust. Then it contains many impurities like sand and crystals. Okay, some small rocks will present on the ore. That kind of impurities like sand and clay. Why the ores contain sand and clay means we are collecting from the earth only? No, we are collecting these ores by digging. Okay, So by mind we can collect this. So that's why they contain sand and clay. Such kind of impurities. That means the impurities like sand and clay are called gangue. Called what? Gangue. So we have to remove this sand and clay from the ore. That process is called as concentration or dressing. The removing of unwanted impurities. The removing of unwanted impurities from its ore is called as concentration and dressing. Okay. Then here the concentration or dressing is depends on some physical techniques. We can do it on physical methods. Here we have some kind of physical methods: hand picking, washing, and flotation and magnetic separation. Okay, we have many, not only these 4 methods, we have many methods to do the dressing or concentration, but you will learn about such kind of methods in your higher classes, right? Then in our 10th class we are going to discuss these 4 kind of methods of dressing or concentration. First one is hand picking. Hand picking means, you know that daily morning mother can collect the pebbles from the rice, okay, from the rice grains. How it is possible? The color of rice is white in color. What are the impurities are present in the rice or in different color than other than white in color? That means pebbles may like in black in color. So that is different one, that is the odd one. From out of the white grains, the black one easily it can appear. Then easily we can collect it. The removing of the impurities from hand is called as hand picking. Okay, it can be possible when the impurity which is present in the ore in different in color or different in size. Got it? Different in size, different in shape, then only we can applicable this hand picking method. Got it? For example, that impurity, the ore, both are in the same in color, same in size, then it is easy to possible to remove it. No, right? So then hand picking is one of the method, one of the physical method. It can be possible when the impurity contains with a different color or different in size. Okay, this is hand picking. Next, washing. Next, washing. How we will do washing? This ore can be make into the fine powder. Make it into the fine powder, and it contains one slopy surface, and it contains the surface, and the powder is dropped on the surface, and water is poured out on the slopy surface. Then water is poured on it. When water is flowing through the ore, powdered ore, then impurities which are lighter in weight, they can float in water and they poured out, they came out. This is a way to we can do the concentration by washing. When it is possible, when the impurity is lighter one. Okay, this method, washing method, can be applicable when the impurity in lighter weight. Okay, right. Then this is one of the method. And here we are going to discuss one more method is called as froth flotation. One more method is called as froth flotation. The most probably this froth flotation can be applicable for sulfide ores. Sulfide ores. Sir, how we will do, sir? Then first of all, the sulfide ore is made into the fine powder, is made into the fine powder, and it is collected in a container which consists of water, okay. Then here the compressed air is sent into the water, okay. In this water we can add some pine oil, and we add these sulfide ores after making into the fine powder, and we can send the compressed air into the water. Then it forms when compressed air is sent into the water, then it forms froth on the container. It forms the froth, and the metals which are in lighter weight, they came out. The metal particles are in lighter weight, they came out with the froth onto the container. Then this froth is lighter weight, no? Then it is easy to collect. Then we can collect the froth and further wash the froth. Then we get the metal particles and remaining residue, okay, that means gangue like a sand or clay particles are present at the bottom of the container. This is the method to do the dressing is called as froth flotation, okay. From this source we can send the compressed air, okay, got it. This is what a froth. This froth contains then metal particles. This we can collect it, and we can collect the metal particle from the froth. This is the gangue, right? This is one method, right, okay. And this froth flotation is most probably is useful for sulfide ores, okay, right. Here we have one more kind of method, one more type of method of dressing is called as magnetic separation. What we call magnetic separation. We have completed for flotation, no? The magnetic separation. Here a magnetic separation contains a belt, okay, like this, right, and finely powdered ore can be dropped on it, and here it has two wheels to rotate the belt. With the help of these wheels, then the belt can be moved, and here one of the wheel is magnet, okay, okay. When the particles or finely powdered particles comes out through it, okay, right, along with impurities. Then the impurities are non-magnetic substances, then they are collected here. All impurities which are in non-magnetic substances, okay, right. Then the magnetic substances which are collected here these are magnetic, okay, magnetic substances. This is a way to separate one of the method is called magnetic separation. Very simple. Magnetic separation contains the belt. On the belt, the finely powdered, crushed, crushed ore can be collected or dropped on the belt. Then belt can moves with the help of the two wheels. Then one of the wheel is magnetic one. When the powder is came near to this near the magnetic wheel, the magnetic substances can struck it to it, and the impurities can fall here. The magnetic ones falls here. That means this method can be possible with the materials or consist. Then the ore should be the magnetic substance. Then only it is possible. These are the few of the methods which can be adapted to do the concentration or tracing. We have more kinds of methods that you will discuss in your further in classes. In our next class, we are going to discuss extraction of crude metal and refining or purification of the metal in our next class. Thank you.